Hi Cub, so we're back with number 39, which is talking about oligopolies. So let's just go over the characteristics of oligopolies, monopolies, and perfect competition. Okay, so let's take a look at the number of sellers and the barriers in each of the different forms of market structure. So in a monopoly, the number of sellers is just one. There's only one seller in a monopoly. And since there's only one, there's no other way to get in, so the barriers are high. Okay, now if we talk about an oligopoly is just a few people who get together. Sometimes they conspire together, but there's just a few sellers in the marketplace. So this is few. And to keep it few, there also has to be high barriers to entry, not quite as high as a monopoly where there's only one, but it's still high entry to getting into the marketplace. So there's high barriers here. And then in competition, really, let's call this perfect competition. There are many, many sellers in competition, and perfect competition especially. So in competition, there are many, many sellers, and there's very little barriers or no barriers to competition. At least there's no barriers in perfect competition, and there are very low barriers in just ordinary competition. So this sets the scenario for barriers and number of sellers for the three forms of monopoly, oligopoly, and competition. So now that we know that, let's take a look at the question and see if we can find the answer, right? So which of the following best describes an oligopolistic market? So A, many sellers. All right away we see many sellers. That's an oligopoly. B says many sellers. So again, that's not going to be right. Okay. C, a few competing sellers. Well, that's good. We got few with similar products and high barriers to entry. So we see that that does fit the bill of an oligopoly. Let's just check out D, a few competing sellers. Well, that's right too. Identical products and no barriers to competition. So we know that there's high barriers to competition here, so that one is going to be incorrect. And then no competition. Well, no competition implies a monopoly, so that will not be correct. So the correct answer here is C. Okay, question 40 is one that we have not seen at all. It's pretty much a game theory problem. There's definitely some key points that we're going to want to understand with this, but instead of just reviewing it as before we do the question, I think this is best if we just do the question and get the concepts by doing the problem. So here we go. The payoff matrix below shows that the per unit profits associated with the production strategy of two utility companies, UA and UB. Each firm has two choices. They could to reduce production by 10% or to reduce production by 20%. The first entry in each cell indicates the profits to UA and the second the profits to UB. So let's first, so we just get some clarity on this, go to this box and then we're just going to mark on here which profit goes to which utility. So we know the first one is UA in the box, and the second one belongs to UB. So let's just analyze the box and see if we could glean anything from this before we get into the strategy. So if UB reduces the production by 20%, then they're going to make $150. That is if also UA also reduces production by 20%. So this box here is the box where both of them reduce by 20%. If they both reduce by 10%, they're only going to make $100 a piece. The problem is they don't know what the other competitor is doing. And then similarly, if UA reduces their production by 20%, but UB only produces by 10%, obviously that's going to be an advantage to UB, and you can see they make a lot more money, $250, and then the profit at UA actually goes down to $50. So how do we use this information to figure out what each of these utility companies' strategy should be? And the way to do this is just to take a look at all the scenarios that could happen. So if you're UB, then UA could either lower by 20% or lower by 10%. And you look at those scenarios and decide what you should do. And then you would do the same thing for UA. So let's ask the question, what should UB do? So from the problem we know that UA could either reduce by 20% or UA could reduce by 10%. Okay, so let's look at UA. Let's say UA reduces by 20%. Okay, so if UA reduces by 20%, we know we're in this on these boxes. Okay, so let's look at UB. So if UB reduces by 20%, then they stand to make $150. And if UB reduces by 10%, they make $250. So clearly in the UA going down by 20%, they have an incentive to reduce by only 10%. So again, UB should go down by 10%. Okay, so alternatively, UA could go down by 10%. So if they go down by 10%, then we're in this box over here. And then we ask ourselves, if we're UB, what should we do? So if we go down by 20%, we're going to make $50. But if we go down by 10%, we're going to make $100. So here too, we have an incentive to go down by 10%, because the 100 is more than the 50. So we see in both cases that UB should always go down by 10%. This is called a dominant strategy. With a dominant strategy, it means that no matter what UA does, no matter what they do, we're always better off doing the same thing. And in this case, reducing by 10%. So now we ask the same question, but for UB, for UA, what should UA do? Now we've already established that UB is going to be reducing their price by 10%. So we know we're in these two boxes here. Okay, so we see that if UA reduces their price by 20%, they'll make $50. But if UA reduces by 10%, they make $100. So in this case, UA has the incentive to reduce by 10% because the $100 is more than the 50. So there's an incentive in both companies to stay in this box, right, where UB is going to reduce by 10% and UA is going to reduce by 10%. And when two companies look at the same scenarios, right, they look at all the scenarios and they come up with only one that they could choose, not different ones, they call that a Nash equilibrium. A Nash equilibrium meaning that in this game theory, in these conditions, both companies only have one option, or one best option. Alright, so knowing that, let's go ahead and take a look at the choices. Okay, based upon the information and assuming no cooperation. Now, it's important to say no cooperation because oligopolies can conspire together, and if they did conspire together, they would just sit in a room and say, listen, why make $100? Let's make $150, right? That's when they're cooperating. But here they're told that you're not cooperating. Which of the following statements is true? Neither company has a dominant strategy. Well, that's wrong because we proved that UA does have a dominant strategy. And actually, if we did the same analysis for UB, we'd find out that they also have a dominant strategy. Both companies have an incentive to reduce production 10%. Well, that is exactly right. It's exactly what we found. It's the Nash equilibrium point. Okay, let's take a look at the next one just to make sure. Both companies have an incentive to reduce production 20%. We know that that is not correct. Only UA has an incentive to reduce 20%, not correct. And only UB has an incentive to reduce 20%, not correct. So the correct answer in this is B. A lot of new concepts here, a lot of things to go over. Probably pays to do a few other examples to make sure you have all the concepts. Alright, so let's continue. Number 41. In order to minimize short-run losses, a profit-maximizing firm will necessarily shut down production under which of the following conditions? So we're talking about not going out of business completely. We're talking about short-run losses. So at this point, the thing to keep in mind is that every business has fixed costs and it has the variable costs, right? So even if you shut down for a time, you still have the fixed costs. So the question is, when would you just shut down your business knowing that you still have these fixed costs? And the idea is that if you could get rid of your variable costs, which you can because they're variable, so if the amount of money that you're taking in, the revenue you're taking in is less than your variable costs, then you're just losing money by making stuff, right? So it's not a marginal thing. You're looking now at the average costs. So I don't know if that was completely clear, but let's take a look at the choices and see if we can make this a little bit more clear. So the total revenue take in is less than the total cost. So that's obviously pretty bad for business, but you don't know what your marginal costs are here. You don't know if you can make some more product or less product and become profitable. So this isn't the scenario we're looking for. Marginal cost is greater than the average total cost. So, I mean, the price could be much higher than the marginal cost and much higher than the average total cost. So, if the price was higher than both of those, you certainly would stay in business. So, that's not a scenario for shutting down. Marginal cost is less than the marginal revenue. Well, that's a reason to stay in business. So, if you can make it for less than what you're selling it for, you want to stay in business, not shut down. So, that's in. Okay, D. Average revenue is less than the average variable cost. Well, here you go. So, you're in business, you're making stuff. You have an average variable cost, right, which you can make go away. But in order to stay in business, you have to expend these average variable costs. But the amount you're making is actually less than the variable costs. So at this point, the more you make, or whatever you're making, is just losing you money. So at that point, yes, you should be shutting down. Okay, we'll just take a look at E. The average revenue is less than the average total cost. So I know it's a little bit confusing, but even though the average revenue is less than the average total cost, so you're losing money, it could very well be that you're not losing as much as you could be if you were shutting down. So remember, so even though it's still less, you could still be making money against your fixed costs. So again, this would not be correct. The correct answer here is D. Okay, number 42, an increase in the effective minimum wage will have less of an impact on employment if the demand for labor is. So let's just have a quick reminder of some of the terms. So a inelastic demand curve is something that's very steep. A perfectly elastic curve is something that's very, very flat. And unit elastic is when the slope is exactly 45 degrees negative. So we see, let's take a look at the inelastic curve. It's very steep. So the quantity, in this case we're talking about the quantity of labor, no matter what happens, the quantity of labor just doesn't change very much. You can see it's very steep. On the contrary, an elastic curve, completely elastic demand, you can see that the quantity could change very great amounts if the price changes. Right? And then unit elastic is just kind of a one-for-one change. Okay, so A, derived demand. Now, I don't think that we've seen that term before. But what a derived demand is when the demand for one commodity is based upon the demand for another commodity. So, for instance, in your cell phone, you have lithium batteries. This is an example that I found. So if the demand for your cell phones increase, then there'll be a derived demand for the lithium batteries that go inside. So that's derived demand. So this derived demand really has nothing to do with this problem, so we can go ahead and rule that out. Okay, B says if the demand curve is decreasing. Well, I mean, inelastic is decreasing very quickly. Here it's unit, and here it's very fast. So decreasing doesn't give us enough information to decide whether or not it's going to, what kind of impact it's going to have in employment if they increase the effective minimum wage. So that's not correct. Okay, C, relatively elastic. So we're on this curve here. So if the minimum wage goes up, you're going to see a tremendous change in the demand for labor. So that is exactly the wrong choice, which makes a relatively inelastic exactly the right choice. So as the price changes, you have a rising minimum wage. The price for labor has gone up, but the quantity demanded doesn't change because it's an inelastic curve. So that is correct. And of course, a unit elastic just means that we'd have kind of a one-for-one change, so it's kind of in between elastic and inelastic. Not correct, or at least it's a better answer to say that D is the answer in this case. Okay, number 43. If a firm employs only labor and capital in its production process, which of the following best describes the optimal combination of inputs for the firm in the long run? Now this is funny because this is pretty much the same problem that they had the wrong answer for on the Quest homework. Remember, when we're going to figure out the best inputs to put in, it's going to be the marginal product per dollar, because we know that you have units of labor and you have units of capital, and the marginal product tells you how it changes per unit of labor and per unit of capital. But really what we want, because labor has different dollar amount associated with it, and capital is a different dollar amount associated with it, we really care about the marginal product per dollar spent. And if we could make those equal, we're going to have a combination that's going to best maximize our inputs in the long run. And if we just go to choice A, the marginal products per dollar spent on labor equals the marginal products per dollar spent on capital, and that is exactly the right answer. Quickly look at the other choices. The marginal product of labor is equal to the marginal product of capital. That doesn't take the cost of labor and capital into account, so that is incorrect. The total product of labor is equal to the total product of capital, again not taking the costs of those into account. The marginal product of labor and capital are both zero, again not correct. And the marginal products are equal to all average products, again the same reasoning. It's got to be the marginal product per dollar spent. So correct answer here is A. Okay, number 44, most economists argue that a monopoly is inefficient because, so I took the opportunity to draw a couple of graphs here, one for perfect competition and one for monopoly. So let's take a look at perfect competition for a second. So we see that there the marginal revenue and the marginal cost intersect at the average total cost. That means there's no profit being made. And the demand curve looks like a flat line at a single price. So we see that the quantity being produced is the most that could possibly be made, and the price could only be one price. So in perfect competition, we're making as much as we can, and the price is as low as it can be, squeezing all the profit out of competition. But on the other hand, if we look at a monopoly, right now, monopoly has barriers to competition. They're the only player, and they actually see a real downward sloping demand curve. And you should make a note of this, that if the slope of a demand curve is -1, then the marginal revenue curve is going to be -2. That's just comes out of the mathematics. But you see the marginal revenue curve is downward sloping, but it's downward sloping at twice the slope. And we can see that intersects the marginal cost curve at a point over here. Okay, now that point is the quantity that the monopoly is going to make, and if you just follow it up, they're going to charge this price up here where it intersects the demand curve. But we know that if it was a perfect competition, you'd be out here. You'd be out here at a price that is lower and a quantity that is higher, right? Because there you'd be hitting the demand curve that you see over here. You've got 1 point. So the difference between a monopoly and competition is that in a monopoly, the price is lower, the price is higher than you'd expect, and the quantity is lower. So keeping that in mind, let's go ahead and take a look at the choices. A has no incentive to minimize its costs. So that's not true. I mean, even if you're a monopoly, if you can minimize your cost, you can make more money. So we know that's not true. B produces too little output and sets a price above marginal cost. Well, that happens to be exactly what we said, so that's true. We'll take a look at the other choices. Earns too much profit by charging consumers any price at once. Well, it can't charge any price at once because there still is a demand curve, so we know that's not right. Produces too much output and then wastes scarce resources, and that's certainly not right. It's only going to make as much quantity where its marginal cost equals the marginal revenue, and usually produces unsafe products if it is not regulated by the government, and I don't see any reason why that would be true. So that's not correct. So here the choice is B.